Ladies and gentlemen, in the name of mathematics, you are welcome. And I will going to present the lesson on cycle theorems, using theorems in cycle on how to prove, how to find unknown angles in Euclidean geometry. This is for grade 11. The presenter is Melulek Shabalala, and I will present this lesson. Here is Melulek Shabalala. A young teacher will present this lesson. Wow, how nice. Okay, first of all, before we move on into our lesson, we have to remind ourselves that failing maths is not an option. And if it was, I was not going to take it. Mathematics. Wow, how nice. Okay, here's a lesson on cycle theorems. Here is the first problem. We're going to do examples on how to solve from angles in Euclidean geometry. We are given that a figure there. In figure there, LQ is a tangent. As you can see, we have our LQ is a tangent to a circle. This is our circle. KLMN at L, and MM is produced to meet S, and MN is equal to KN. MN is equals to KN. Determine with reasons the size of the following angles. Then they need L2, this is our L2, and they need N1, this is our N1, and they need what? M2, this is our M2. Okay, before we approach problem, the most important thing in Euclidean geometry, before we approach problem, we don't know there's something we don't know the question. Let us focus in our diagram and find all the angles that we can find, and then we can move to our equation. Okay, but we know that we are told that this is a tangent. We have our tangent there, and this is what? This is a chord. Then bring that thing. They were, as even there we are told that is a tangent. Then Dr. Kipton said we have to bring the facts that we know about the tangent. What we know about the tangent? We know that the angle between the tangent and the chord is equal to the angle subtended by that chord into the alternating segment. We know this angle, we're talking about this angle, and this is our chord. Then it means our alternating segment. Now let's just move on from here now to there, our alternating segment. It means now what? L2 equal to what? 48. For reason for that, Tanakot theorem. Wow, how nice. We have that one equal to 48 degrees, and we have that one equal to 48 degrees, and we have that one equal to 48 degrees. What else? Wow, hang on. What else? Okay, we are told that MN, this is our MN equal to what? KN, and this is a triangle KNM. We're given that MN equal to what? KN. Wow, how nice. We're saying, okay, this one equal to this one, and we're given that equal to 25. Wow, what can be your conclusion about that one? Because we're giving an isosceles triangle there. Wow, how nice. Even this one would be equal to what? 25 degrees, because base angle is of what? Of an isosceles triangle. Wow, hang on. Can you see now? How nice is this thing? Can you see now we have this 25? And we have that 25, and we don't know that one, and we have a triangle there. But can you find this one? Because we have these two. How can you find that one? We know that the sum of the angles in a triangle equal to what? 180 degrees. Wow. If we say 180 degrees minus these two angles, we got that one equal to what? 130 degrees. Wow, how nice. Hang on. Can you see now? I have that one, N2 equal to 108. And I have N1 there equal N1 there, but they're in a straight line, right? It means if I add N2 plus N1, I get what? 180 degrees, because they're in a straight line. Wow, how nice is mathematics. So now, how can I get N1? It means now I can say 180 degrees minus that 110 that I get N1 equal to what? 50 degrees. Wow, how nice is mathematics. Can you see now I have K, N, M, N. Wow. Can you see that one? It is a cycle quadrilateral. How do you know? What do you know about cycle quadrilateral? You know three things about the cyclic quadrilateral. I have cyclic quadrilateral K, L, M, N. Wow. How can you conclude about N1 and L1 there? Wow, you know that the exterior angle in a cyclic quadrilateral equal to the interior opposite angle. It means now even L1 will be equal to what? Wow, will be equal to 50. The reason for that, exterior angle in a cyclic quadrilateral. Hang on. Wow, can you see now I have K, L, M. That one, it is called what? A triangle there, that one. It is a triangle. Can you see? And I have that one equal to 48 degrees. And I have that one equals to what? 50 degrees. Can I find that one? Because I know that the sum of the angles in a triangle equal to what? 108. How can I find that one? Wow, how nice. It means I can say 180 minus the sum of these two angles, 48 and 8. It means 100. It means if I can say 180 degrees minus the sum of that one. That is the sum of that one. If I add 48 plus 50, I got what? 98. If I say 180 degrees minus 98, I got M2. What is my M2 there? What is my M2? Equals to 82 degrees. Wow, how nice is mathematics? We just use the facts that you know before you solve problems. That you know, use those facts before you solve problems. Once you cover that one, then you can now go to the questions. Now we have our 2.1 there. What is the question for 2.1? They say find our L2. Wow, how nice. Our L2 already have our L2 equal to 48 degrees. L2, we have that one. We have a tangent. We have a tangent there. We are told that LQ is the tangent. This is our tangent, and LM is the chord. We are told that LM is the chord. Now the angle between the chord and the angle between the chord equal to the angle subtended by that chord in the alternating segment. It means L2 equal to what? K1 there. Wow. 2.1. I have our angle L2 equals to 25 degrees. L2 so equals to 82. So it should be 82 degrees. L2 not 25 degrees. Our L2 it should be that 48 degrees, that one, because equal to that one, not instead that 25. Very mistake there. It should be what? 48. It means our L2 equal to what? 48 degrees. Wow, how nice is mathematics. Let us move on. Now we have to find what now? Now we have to find 2.2. They say in 2.2, find our N1 there. Find N1. Where is our N1? It is there. You already have that one. Base angle of a triangle. How can we find L1 there? We have K2 equal to M1. That one. K2 equal to M1. The reason for that, base angle of a triangle, because we are given that Kn equal to that one, means that one are equal. Then equals to 25 means K2 equal to 25. Wow, how nice. You see now I have that 25 and I have that 25. What conclusion can you make about that 25 M1 and K2 related to N1 there? Because you have to find N1 there. But you know that the exterior angle of a triangle equal to what? The sum of the interior angle. Wow, it means N1 will be equal to what? K2 plus what? M1 there. It means N1 will be equal to what? 50 degrees. The reason for that, exterior angle of a triangle. If I have exterior angle equal to the sum of the interior angle, if I add that 25 plus 25, I got 50. That's why N1 equals to 50 degrees. Wow, how nice is mathematics. But you can use another method to find N1. Let's just use another method. Are you ready for another method? Wow, how nice. Okay, you see that this one plus this one equal this one and this one, and I add, then I get that one 180. Then in a straight line I can find that one. Let us use that one. I know that N2 equal to 130 degrees. N2 equal to 130. I have already shown that. Use angle, sum in a triangle, sum of the angles in a triangle. I know that. And I know that now N1 plus N2. n1 plus n2 equal to what? 180 degrees, because they are in a straight line, angle is in a straight line. Then I know my n1, I know my n1, I got n1 there equal to what? 180 degrees. Substitute your n1 there and solve for n2. That's n1. Then we get our n1 equal to what? 50 degrees. Wow, how nice is mathematics. Now the last one, they say calculate m2. Let's just follow step how to calculate, how to go about calculating n2. We know that we can use that one. How can you find that when you have that angle? We have that angle. When we have that one, only what we need to find m2 there. But we know that the opposite angle is in a cyclic quadrilateral add up to what? 108. If I say k1 plus k2 plus m1 plus m2 equal to 108. As you can see, k1 plus k2 plus m1 plus m2 equal to 180 degrees. Because the reason for that, opposite angles in a cyclic quadrilateral. Then you substitute your k1 there. Where is your k1? 48 degrees. Then k2 equal to 25 degrees. m1 equal to what? 25 degrees. Then we need to find what? m2. Then solve for m2. We got our m2 equal to 82 degrees. Wow, how nice is mathematics. Can you use another method for that one? Yes, we can use another method. Now let's follow that method. You know that L1 equal to N1. So that L1 equal to N1. The reason for that, the exterior angle of a cyclic quadrilateral. Okay, that's why that one, we have N1 equal to L1. But here, can you say that now? In triangle KLM, we know that one equal to 50 degrees and that one equal to 48 degrees. Can you find that one? Yes, because we know the sum of the angles in a triangle add up to what? 108. It means if I add to K1 plus M1, plus L1 plus M2 equal to what? 180 degrees, because sum of the angles is in a straight line. Then we know my K1, substitute your K1 there. I know my L1, substitute your L1 equal to 50. Then solve for M2 equal to what? M2 equal to 82 degrees. Wow, how nice is mathematics. Just do it. Okay, now let's just do another example, still on cyclic theorems. Wow, are you ready for the second one? Okay, here we're given that one. In figure AP and BP are tangents. We are told that AP, this is our AP and PP. We're given that this is our PP. Our change in the circle A and B. C is a point on the circle side that AC equal to CB. AC equal to CB. Wow. Before you solve question, they say AC equal to BC. And you have a triangle there, but they say AC equal to BC. We know the base angle is a triangle, but we are not there. Let us continue with our problem. AB is extended to C such that PQ is parallel to CB. We have our PQ is parallel to CB. Wow, they talk about parallel lines. Bring the facts that you know about parallel. What do you know about parallel lines? You know the alternating angles that are equal. You know the corresponding angles that are equal, and you know the co-interior angles that are equal to what? 180 degrees. But we are not there. Wow, how nice. Let's continue with that one. Then the AC is extended to meet PQ. This is our AC. So extended to meet PQ. This is extended to meet that one. And let's say BPR equals to X. BPR. We have our BPR equals, it means that angle equal to what? X. Then 6.1, the question say, write down with reason 5 other angles that are equal to X. We know that equal to X, and we are told this is the parallel lines. They say, now let's just find another angle that are equal to X. They say BC is parallel to QP. Then, wow, What do you know about parallel line? You can find alternating angles. How can we conclude about P2 and P3? What do you call that one? They form a Z shape. We have a P3 and P2. That's equal to X, alternating angles in a triangle there. That's why I say 6.1, and then the first angle they say we have to find 5 other angles that are equal to X. We know that our P2, this is our P2 equal to what? P3 and equal to X. The reason for that, alternating angles. This one alternating angle, since we are told that BC is parallel to PQ. Wow, how nice. Let's find another one now. That's equal to X. And we are told that BP, then we are told that PP, this one PP is a tangent. What do we know about tangent? Okay, we know that this is our B2, this is angle between, this is our tangent, and BC, this is our what? Our chord. What do we know about the angle between the tangent and the chord? What do you conclude about B2 and A1? Wow, you know the angle between the tangent and this one, the chord, therefore the angle in the alternating segment, the A1. Now, wow. Conclusion now, B2, our A1 now, A1 equal to B2, also equal to X. The reason for that, the tan chord theorem. Wow, we have now our A1. But we are told that AC equal to BC. How can you conclude about A1 and B1? Wow, A1 equals to B1. The base angle is on this triangle. Therefore, A1 equal to B1 equal to X. The reason for that, base angle is a triangle. Since we are told that AC, this is our AC, equal to BC. This is our BC. Then you get that answer. Wow, how nice is mathematics. Let's just enjoy this thing. Now, let's find another angle now. We have that angle and we have that angle. Now, this one equal to X again. But here we are told that AP is a tangent. AP is a tangent and AC is the chord. What do you know about the angle between the tangent and the chord? Between the tangent and the chord. The angle between the tangent and the chord equals to the angle subtended by that chord to the alternating segment. It means that one, this is the segment AC. The angle that equal to, then if you move on there, it means we get our B1 and A2. What can be your conclusion between B1 and A2? Wow. B1 equal to what? A2. The reason for that, tan chord theorem. Wow. Number 4. A2 equal to B1. A2 equal to B1 and equal to X. The reason for that, the reason for that, so not supposed to this both angle of the triangle, it should be the tan chord theorem, that one. Tan chord theorem, A2 equal to B1, A2 equal to B1. The reason for that, tan chord theorem, not that one. Tan chord theorem, you know that one. Then, can you find another one? What is the another one? They say we have 5 angles. How can you find another one now? Wow, how nice is mathematics? What can you find? Can you find another angle now? Let's just look for another angle now. But you know that these are the parallel lines, and you know how to conclude about B1 and Q there. B1 and Q there. B1 and Q. Wow, you know that Q and that one are the corresponding angles between, since PQ is parallel to BC. It means we have our corresponding angles there that form F shape. This is our F shape, corresponding angles. That means A1 equals to Q there. But even now, you can, another one, B1 equal to A2. B1 equals to A2. That one. So this is repeated. This one, A1, B1 equal to, this is number 4. It should be that one, B1 equal to that one. Tan chord theorem, already discussed that one. What you want to discuss, that one, B1 equals to Q, the corresponding angles. That's why I have B1 equal to Q equal to X, the corresponding angle, since BC equals to PQ. Wow, how nice is mathematics. I hope you enjoy that one. Now, let's just look for another one now. Now, for 6.2, they say prove that ABRP is a cyclic quadrilateral. Prove that ABRP is a cyclic quadrilateral. What do you know about cyclic quadrilateral? Bring 3 facts about quadrilateral. About cyclic quadrilateral. These are the 3 facts about cyclic quadrilateral. To prove that this is cyclic quadrilateral, you can show either opposite angles as supplementary, or you can use that one, the angle in the same segment are equal, or you can use that one, the third one, the exterior angle is equal to the interior opposite angles. Here now, let's just look this one now. Wow. Which one now? Can you see the triangle A, B, R, P? Can you see that we have that BR subtended which angle? BR subtended angle at A1 and subtended what? Angle at P. We know the angle at P equal to what? X. And A1 equal to what? We said A1 there. A1 equal to what? Equal to P1 equal to X. And P3 equal to what? P3 equal to P2 equal to X. It means A1 equal to X and P equal to X. But they are subtended by same code, same segment. They're coming from BR. They subtended the angle there at P3, and there is very same BR subtended the angle at what? A1 means A1 equal to X. How can you conclude about now traffic A, B, RP? Because there's a very same PR subtended angle there as subtended angle there. But there, if they prove that is a quadrilateral, we know that A1 equal to P3. Our A1 equal to P3 equal to X as shown above. Then our below conclusion there that we can conclude that ABRP is a cyclic quadrilateral. What is the reason for that? The angles in the same quadrant. Therefore, ABRP is a cyclic quadrilateral. The reason for that, angles in the same segment. Wow, how nice is mathematics. Then I hope you enjoyed this video. Please watch my other videos there. This is all about how to prove cyclic quadrilateral. I hope everything is clear there. If you have any question, you can ask me anytime. Okay, that is the end of this video, and thank you for your attention. If you have questions, here my email address, melulekeshabalala@gmail.com. Here my cell phone number, 07333 And let's just do this thing. Let's just enjoy mathematics. Let's just do this thing and enjoy the sing our nice song titled How Nice is Mathematics, and enjoy the beauty of mathematics. Wow, how nice is mathematics. Siyashonke simabudede ubumnyama kuvela ukukhanya kwe-mathematics.